When people first learn about testing, they often imagine it as a final checkpoint where someone clicks through a few screens, confirms the app seems to work, and then declares it ready. That approach might catch obvious breakages, but it is exactly how security behaviors get missed, because security often shows up in the edges of normal use rather than in the main happy path. Functional acceptance testing is meant to confirm that a system meets its intended requirements, and for security architecture, that includes the behaviors that protect data, enforce permissions, and preserve trust. If acceptance testing is built only around features, you can ship a system that looks correct but quietly violates core security expectations. This episode focuses on how to verify a design using functional acceptance testing in a way that reliably includes the security behaviors the architecture depends on. The key idea is not learning a complicated testing framework, but learning to translate security design decisions into observable behaviors that a tester can confirm. When you can do that, security stops being an invisible promise and becomes something you can demonstrate. Before we continue, a quick note. This audio course is a companion to our course companion books. The first book is about the exam and provides detailed information on how to pass it best. The second book is a Kindle-only ebook that contains 1,000 flashcards that can be used on your mobile device or Kindle. Check them both out at cyber.author.me in the Bare Metal Study Guide series. Functional acceptance testing is about confirming that what was designed is what was built, as seen from the outside through normal system behavior. It does not mean you have to inspect internal code or run specialized tools, and it does not require the tester to be an attacker. Instead, it asks whether the system behaves as expected when real users and real workflows interact with it. For security, that means confirming that authentication works the way the design requires, that authorization boundaries hold, that sensitive actions are constrained, and that the system fails safely when inputs are wrong or access is denied. One reason beginners miss security behaviors is that they assume security is a separate layer, like a lock installed after the house is built. In modern systems, security is often baked into workflow decisions, session handling, role checks, data filtering, and error handling, which all show up as functional behaviors. Acceptance tests are your chance to prove those behaviors exist and are consistent across the system. If you approach acceptance testing with the mindset of verifying trust boundaries and permissions, you catch issues early that are much harder to fix after release. A useful starting point is recognizing that security behaviors are often expressed as requirements, even if they are not labeled as security. A requirement like users can view their account details has an obvious functional test, but a related security requirement like users can only view their own account details is the real boundary you must verify. That extra word "only" is where the risk lives, because many systems accidentally let users see or influence things they should not. The same pattern appears in administrative features, reporting, file access, and integration interfaces. Security behaviors also include requirements about how the system responds to invalid conditions, such as refusing access gracefully, not leaking sensitive data and error messages, and maintaining consistent state when an action is blocked. When you read requirements with a security lens, you look for verbs like view, change, approve, export, and delete, and you ask who can do it and under what conditions. Acceptance testing should include checks for those conditions, not just checks that the verb is possible. This is the difference between verifying functionality and verifying security behavior embedded in functionality. To avoid missing security behaviors, you need a way to map the architecture's security decisions to specific observable outcomes. Architecture decisions often include things like role separation, least privilege, segmentation, session boundaries, and protected data flows. Each of those should translate into something a tester can see, such as being prompted to authenticate, being denied an action, seeing a subset of data, or being forced through an approval step. For example, if the design includes role-based access control, then acceptance testing must include multiple user roles and verify that each role sees the correct functions and data. If the design includes separation between standard and privileged actions, then tests should confirm privileged actions require elevated permissions and are not available through normal workflows. If the design requires secure defaults, then tests should confirm the system starts in the safest reasonable state rather than allowing broad access until someone locks it down. The point is that architecture choices are not abstract. They are supposed to change behavior. If acceptance testing cannot detect the behavior, you may not have defined the requirement clearly enough. One of the most important security behaviors to verify functionally is authentication, because many other behaviors rely on identity being reliable. Acceptance testing should confirm that the system requires authentication when it should, that it does not accidentally allow access without a valid session, and that it handles session transitions safely. This includes simple things like confirming that protected pages or functions cannot be reached by someone who is not signed in, and confirming that signing out actually ends access rather than leaving a session usable. It also includes verifying that authentication prompts appear at the right times, such as before sensitive actions or when a session has expired. Even without focusing on a specific mechanism, you can verify behaviors like consistent enforcement across different entry points, such as web and mobile interfaces or different navigation paths. Another behavior to watch is how the system reacts to repeated incorrect login attempts, because it should not be trivial to guess passwords endlessly. You do not need to test every possible edge, but you should confirm the existence of safeguards that the design assumes are present. If authentication behavior is inconsistent, that inconsistency often signals deeper architecture issues. Authorization is the second major area where functional acceptance testing often misses security behavior, especially in systems with many roles, departments, or data ownership rules. Authorization is about what an authenticated identity is allowed to do, and functional acceptance testing should validate both allowed actions and disallowed actions. Beginners sometimes think tests only need to prove that the right people can do the right things, but security depends just as much on proving that the wrong people cannot. A design might specify that regular users can update their own profile, but cannot change billing settings, and an administrator can manage users, but cannot view certain sensitive personal information without an additional approval. These are not exotic requirements. They are everyday boundaries that matter. Acceptance tests should use realistic identities that represent different roles and confirm the boundaries by attempting actions that should be blocked. If you only test allowed workflows, you create a blind spot where broken authorization can go unnoticed. The best acceptance tests treat not allowed as a first-class expected behavior, not an afterthought. Data handling is another area where security behaviors hide inside normal features, and functional acceptance testing can validate it without needing deep technical access. If the design says sensitive data must be protected, then acceptance testing can confirm that users only see the minimum data they need and that exports or reports do not include extra fields by mistake. This matters because many real-world breaches involve overexposure through perfectly functional features like search, reporting, or file sharing. Tests can confirm that data is filtered based on user identity, role, and ownership, and that the system does not accidentally reveal hidden data through sorting, autocomplete, or error responses. Another important behavior is how the system handles data when access is denied. For example, it should not show partial sensitive information before blocking the action. You can also verify that workflows that involve transmitting or sharing data apply the right constraints, such as requiring explicit confirmation for sensitive exports. The goal is to confirm that the system's normal outputs align with the architecture's data protection decisions. If data exposure is wrong, the system can be working while still failing security. Error handling and failure behavior deserve special attention because they are easy to ignore in acceptance tests, yet they frequently contain security weaknesses. A secure design expects that when something goes wrong, the system fails safely, meaning it does not grant access, does not corrupt state, and does not leak sensitive details. Functionally, you can test this by triggering common failure conditions, like trying to access a resource that does not exist, submitting an invalid input, or attempting an action without permission. The expected behavior might be a generic error message and a consistent denial, rather than revealing internal details about the system. You should also check that failures do not create inconsistent outcomes, such as partially completing a sensitive action before rejecting it. For example, if a transaction requires approval, the system should not commit changes and then later claim the approval failed, because that breaks trust and can be exploited. While acceptance testing is not a deep security audit, it is the right place to verify that failure paths behave consistently and safely. If the system's error handling is chaotic, security behaviors are usually chaotic too. Another frequently missed area is workflow integrity, which is the idea that multi-step processes cannot be bypassed or rearranged in unsafe ways. Many systems depend on sequences like request, review, approve, and execute, and the architecture assumes those steps enforce control. Functional acceptance testing should verify that steps cannot be skipped, repeated improperly, or performed out of order by someone who should not be able to. For example, if a user must accept terms before gaining access, you should verify that access does not appear without that step. If an administrator must approve a change, you should verify that the change cannot be executed without approval and that approval is tied to the correct request. You also want to verify that the system keeps accurate state throughout the workflow, such as tracking who initiated and who approved. These behaviors are security relevant because bypassing workflow often leads to unauthorized actions or fraud. Acceptance testing that focuses only on whether the workflow can be completed misses whether it can be abused. Logging and audit behavior can also be verified functionally, even though people often assume it requires internal access. From a functional perspective, you can verify that certain actions create visible audit records and interfaces designed for oversight, such as an administrative history view or an activity log. If the design requires auditability, then acceptance testing should confirm that key actions show up with the right context, like who did what and when. You do not need to inspect raw log files to validate the existence of audit behavior, although deeper validation might happen later in security testing. The key is that acceptance testing should treat auditability as a requirement, not as a bonus feature. If the system has administrative functions, it should provide a way to review activity and detect misuse, because that is part of how many architectures manage risk. Another important behavior is ensuring that denied actions are sometimes logged appropriately, especially if repeated denials could indicate probing. You are verifying that the system supports accountability in a way that matches its intended security posture. To make acceptance testing effective without missing security behaviors, you also need to be careful about coverage across interfaces and integration points. A common architecture weakness is that one interface enforces controls correctly while another interface, like an application programming interface, behaves differently. Even for beginners, the concept is simple. If the system offers more than one way to do something, you should verify that the same security rules apply everywhere. That means testing the same functional behaviors through each major entry path that real users or systems use. The goal is not exhaustive testing, but confirming consistency, because inconsistency is where unauthorized access often appears. Another issue is default behavior, such as what happens when a feature is enabled but not configured or when a new user is created. Acceptance tests should confirm that defaults align with least privilege and do not create broad access accidentally. If the design depends on secure defaults, you must validate them explicitly. Otherwise, the system might pass feature tests while failing in the first hour of real use. It also helps to understand the difference between functional acceptance testing and other forms of testing so you do not expect the wrong thing from it. Functional acceptance testing confirms intended behavior from a user perspective, which is excellent for verifying that architectural security decisions show up as actual behavior. It is not the same as penetration testing, which tries to break things, and it is not the same as code review, which inspects implementation. But functional acceptance testing can still catch serious issues early, like missing authorization checks, broken workflows, overexposed data, and unsafe failure behavior. These are some of the most damaging security problems because they are simple and often exploited. If you build security behaviors into acceptance criteria, you reduce the chance that a system is declared done, while the architecture's security promises are unfulfilled. This is why architects often advocate for security-aware acceptance testing as part of quality, not as a separate activity. It keeps security closer to design intent and reduces late-stage surprises. As you move from design to verification, the most practical mindset is to treat each important security decision as a behavior that must be observed and confirmed. If the design assumes authentication gates, then you verify authentication gates in realistic scenarios. If the design assumes role boundaries, then you verify those boundaries by proving both allowed and denied actions. If the design assumes data minimization, then you verify outputs and exports are appropriately limited. If the design assumes safe failure, then you verify the system behaves safely when things go wrong. This approach keeps acceptance testing from becoming a shallow checklist of feature clicks, and it keeps security from being an invisible assumption. Over time, you will find that many security behaviors are simply good system behaviors that increase trust and reduce confusion for users. When acceptance testing confirms them, you have stronger evidence that the system matches the architecture, not just in what it does, but in how safely it does it. That is the real purpose of verifying design with functional acceptance testing, making security behavior observable, reliable, and difficult to accidentally omit.
Thanks for listening. For more audio courses, daily newsletters, and more, please visit baremetalcyber.com.